Pop-up boats can be a very fun pastime for people who enjoy boats or like to work on projects. But there's a lot of science that goes into the functioning and the building of these pop-up boats. So my goal is to explain the complicated, but at the same time very interesting science behind pop-up boats. Now, it wouldn't be very much of a boat if it wasn't able to float. And how the boat floats is because of the buoyant force. And the buoyant force is caused by the collision of water molecules on the surface of the boat, as you can see, like I've drawn here. The water molecules collide with the surface of the boat, and in turn, the boat is able to stay afloat. Now, you know that the force of gravity has to equal the buoyant force because Newton's first law says that every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. So, in this case, the object is at rest and it's not accelerating in any direction horizontally or vertically. Now, looking at it vertically, because it's not accelerating in any direction, we know that the forces acting on it must basically equal each other or cancel each other out. So, by that sense, we have to know that the force of gravity will equal the buoyant force. And that this equation right here basically exhibits that. This equation here will best help to explain how heat is transferred from the candle to the water, and it'll also explain some more factors about how the heat is transferred and how good of a conductor that the metal will be for heat. Now, when you put a candle underneath the engine, the molecules surrounding the candle will begin to move at a really fast speed and will also have a really high temperature. Now, what that does is that heats the metal, and based off this equation here, we can see that metal is a really good conductor of heat. Its K value is really high, and because K is proportional to Q over T, that means more heat can be transferred from the metal to the water. And because more heat can be transferred from the metal to the water, the temperature of the water can increase and it can better form steam. And that's essentially how the heat is transferred. Now, some factors that would affect heat transfer could be the distance between the engine and the flame. Now, looking at the equation, some other factors that could affect heat transfer are the cross-sectional area of what's being heated and the thickness of the metal of the engine. Now, we can see that the cross-sectional area of what's actually being heated is proportional to Q over T. So the bigger the cross-sectional area of what you're heating is, the greater the heat transfer will be. So if you had a larger flame, or you shape the engine in such a way that more of the surface will be in contact with the flame, more heat will be transferred. Also, another factor that affects heat transfer is the thickness of the metal. Based off the equation, we can see that Q over T is proportional to 1 over the thickness of the metal. And what that means is the less thick the metal is, the better it can transfer heat. So if you were to decrease the thickness of the metal here, more heat will be transferred, and thus it will be easier to bring the water to a boil, and the heat can be better transferred in that way. So now I'm going to go over the 4 processes that actually allow the boat to start moving. So process 1 involves simply just adding heat into the engine. Now the pressure begins to increase here as the temperature of the water begins to increase. At this point, the water molecules are trying to overcome the intermolecular forces in between each other and go from the liquid phase to the gas phase. The volume isn't beginning to increase yet because the steam hasn't quite yet been formed. And we can say that there's no work being done on or by the system because the volume isn't changing in any way. So no work is being done on the system. Now, process 2 actually is the formation of the steam. Now here, the steam begins to form and the volume begins to increase. The steam begins to push on the edges of the engine, and the engine begins to expand. Because the engine begins to expand, based off this equation here, we know that the gas molecules on the inside are doing positive work, while the engine itself is having negative work done on it. Now, the pressure on the inside of the engine here is really high, and the pressure on the outside is really low. Now, we know that the gas is doing positive work, and this positive work combined with the difference in pressure is what essentially helps the boat to propel forward. Because there's a lot of force due to the high pressure on the inside here, the water molecules will begin to escape the engine to the area of lower pressure. And that positive work being done by the gas is essentially what helps to propel the boat forward. Now, process 3 simply sees the pressure beginning to decrease in the engine because now the steam has completely escaped, and the pressure, because there's no steam anymore, the pressure lowers. And we know that there's no work being done on or by the system because the volume's not changing in any way based off this equation. And also here, because the steam has escaped and the pressure here is lower, the engine begins to have lower pressure and the outside has higher pressure. And again, because of the differences in pressure and how forces act, water will begin to be pushed inside the engine. So process 4 happens after the water has finally come into the engine, replacing the steam. Now here the engine begins to contract because the steam is no longer in the engine, the water is, and the water occupies a smaller volume, so the engine will contract to fit the shape of the water. And here the volume begins to decrease while the pressure stays constant. Also, in terms of work, since the engine is beginning to contract, we know that the gas molecules are beginning to have positive work done on it, which also means that there is negative work done by the gas, and that bears in contrast to process 2. Also, in the cycle, when you look at process 2, the negative work that's done on the engine is going to be much, much greater than the positive work done on the engine in process 4. And it's this difference in the work that essentially helps to power the boat forward. Now, the other physics topic that I would like to bring up is the idea of volume flow rate and how that affects the speed of the boat. Now, what the volume flow rate basically says is that if you have a tube and you take any multiple different points on that tube and you look at how much fluid is passing through those points over a given period of time, the amount of fluid that passes through those points at any point in the tube has to remain constant. And that's because of one of the greatest universal laws, that matter cannot be created or destroyed. And a great way to conceptualize this, or to better understand it, is if you think of a two-lane road merging into one lane. Now, the cars in the two-lane road are moving really slowly because there's a high volume of cars here, and they're all trying to merge together into this smaller one-lane road. So here, they're going to be moving really slowly, and once they finally get into the merge, they can move much faster because there's not much being obstructed. And basically what this highlights is this equation up here, is that if you have a greater cross-sectional area, the velocity of the molecules passing through the straw or the tube will be slower. And the lower your cross-sectional area, the higher your velocity. Now, in the boat, if you were to narrow the end of the straw, the water molecules would eject at a much higher velocity. And if you take a look at the law of conservation of momentum, which basically says mv is equal to mv, you know that if the velocity of the water molecules are being ejected is higher, then it's going to have a greater momentum. The system is going to have a greater momentum. And because momentum must be conserved through the system, because the total momentum here is higher and the mass of the boat stays the same, that would mean the velocity of the boat traveling in this direction would have to be higher. Um, Unfortunately, we weren't able to incorporate this in our own boat, but because of time constraints. But you can see how the idea of volume flow rate can really help to make our boat move faster. So thank you for watching. I hope you gained a lot of knowledge through watching this video, and you can revel in the science and the complexity of pop-up boats.